Hello everyone and welcome back to another video in our Autodesk Inventor professional tutorial. In this video, we're going to talk about the drive constraints. Drive constraints are very fun to work with because it helps us to use the constraints between two objects to move one object from point A to point B, kind of simulate that motion. And it's really useful, especially when you're working with different assemblies and with some automation equipment, for example. You can kind of see how they would move when they are actually fabricated and assembled. So in this video, we're going to talk about how the drive constraints function. And as you know, in this tutorial, if you've been watching the tutorial since the beginning, we don't really give homeworks. We don't expect you to design the parts. We design them in the video. It's a good way to exercise, everything that we covered so far. So we're going to create two 3D objects, and we're going to put them in an assembly. We're going to move the object 1 on object 2. So let's go to the drop-down menu on the top left corner and select Part. And that will take us to the part mode for part 1. And in part 1, let's start our sketch by clicking on Start 2D Sketch, and let's select XY plane. And now let's go to the drop-down menu under the rectangle feature and select 2-point center rectangle. And select the origin point and start drawing a rectangle. You don't really need to, pay attention to how big or small the rectangle is. You can start entering the dimensions right away. I want this to be my rail. So this is going to be some kind of a path where I can move the other object on. So I want this to be a little bit longer than just a square rectangle. So I want it to be maybe like 500 millimeters. And for the width, I want it to be 120 millimeters. So, and then let's finish the 2D sketch and extrude this. Right click, extrude, and I want this to be 10 millimeter thick. So the object is going to slide on this rail, so I want this to be 10 millimeter in thickness. Let's right click and select new sketch and select this surface now. And right click and project geometry. That way we can take advantage of the existing edges of the object we already created. So let's select this face. Now we have the edges. Now let's use a very simple method to create some sidewalls so the object on top of the rail will not fall off. I mean, it wouldn't, but we're trying to make it more realistic. So let's draw a line here. Notice that I'm not paying attention where the line is because I will add dimensions later. Again, go to the right-click menu and select Create Line and draw another line here. Now we can add dimensions to it from this top edge to this line. Let's say this is 10 millimeters. And I want the same dimension here, but instead of entering the dimension, I'm going to select this 10 millimeters here. So I'm using the parameters. So every time I change this, this will change as well. Now let's finish 2D sketch and right click, extrude, and select this top section and this bottom section. And let's say this is 20 millimeters tall. And I'm sure you're already thinking like you could have used so many different ways to do this. You could have drawn smaller rectangles and you could have used the mirror pattern. You could have just done this one wall on the top side and you could have mirrored that. There are so many different ways to do this thing, but I intentionally did it using the lines because I don't think we've done that before. So, and it's a very simple way to do it. So this is our first part. Let's design the second part now. Go to the drop-down menu on the top left corner and select Part. That will take us to Part 2. And in Part 2, we will select Start 2D Sketch and select XY plane. And let's draw another rectangle using the 2-point center rectangle, using the midpoint, origin point. And I want to enter the dimension here, but I want it to fit in the rail between those walls that I just generated, and I forgot. It can happen to you. I know this is a very simple design, but as you're working with complicated parts, you may forget what dimensions you added, so you want to make sure, right? Let's just, not dimension this, and let's just finish this 2D sketch and go back to part 1, and let's just measure that, and go to that sidewall, to this sidewall. This is 100 millimeters. Remember that we actually entered 120 millimeters here, but used 10 millimeter of wall thickness here, 10 millimeter of wall thickness on the other side. That took 20 millimeters away from us, and now we have 100 millimeters in the middle of the rail. So now let's go back to part 2, double click on sketch icon, not the text, and that will take us back to the sketch mode. Now we can enter 100 millimeters here for the width, but I want to give 1 millimeter clearance, so that will be half a millimeter from one side, half a millimeter for the other side. So I will just enter 99 millimeters here. And let's make this a square box, so I will also enter 99 millimeters, but I will use this 99 millimeters that I already entered, so it's going to make it easier for me. So it's 99 by 99 square. And let's finish that 2D sketch. Now extrude it, right click, extrude, and let's enter maybe 120 millimeters. So now I have my second object also designed as well. Let's start an assembly now. And as you know, we could have started the assembly from the beginning and we could have created these parts in the assembly as well. We already talked about different ways to create parts and add parts in an assembly. In this case, we're gonna be lazy a little bit and we're gonna go to part one, select part one in the feature manager, feature tree on the left, and hit Control C on our keyboard. That will copy the part. We will go to assembly one and Control V on the keyboard. That will paste the part one in the assembly one. And let's go back to part two this time. And part two, Control C on our keyboard, go back to assembly one, Control V, and that will bring part two. That will copy paste part two in the assembly. And assembly, as you know, is a container. Now assembly one contains part one and part two. Notice that part one is the first part, so that's why it's grounded. So when I try to drag it around, it's not going to move, but part two will freely move. So just to be able to separate these parts, I want to just change the colors. I will highlight this part one and go to the top, the color. I believe this was the adjust. Yes. I will go to adjust and maybe select this brownish color for it. And maybe go to the part two and go to adjust and this time select this purplish color. And okay. So now I have part one and part two, and I will constrain these two components in the assembly. So let's start with the bottom of the box. So we will select the bottom surface of the box and the top surface of the rail. And that will constrain those surfaces together, those two components from those surfaces. So let's hit apply. And remember that the width of this object was 99 millimeters, but the distance between two walls from this wall to this inner surface of this wall is 100 millimeters. So I want this box to be centered in the rail, so I will give half a millimeter of clearance. So right click, constrained, select this face with this inner face of the wall, and I will go to offset and enter 0.5 millimeters. Now notice that it will leave half a millimeter of gap on this side and half a millimeter of gap on the other side. So I have some clearance between the box and the rail. So now I apply two constraints. If you expand these part one and part two in the feature manager feature tree, you'll be able to see that mate one and half a millimeter other mate is also listed here, which means that this part can only move this way. And that's going to help us with the drive constraint. So let's add our third constraint, which is going to be the flush constraint. So right click, go to constraint, select this surface, select the flush solution for the mate type, and select this face of the rail. Now the offset is 0, which means that this surface of the box is flush with this surface of the rail. And if you change the offset to, say, 5 millimeters, you can see the preview is changing with a 5 millimeter offset. Let's go back to 0. And let's hit apply. Now it is also flush, and I should not be able to move it around when I hold it and drag it. It doesn't move because it is fully constrained. But now I can select this flush constraint and right click and go to drive. Now I can select, for example, it's the start point is 0 millimeters, so it starts from the 0 millimeter point, but it ends at 10 millimeters. Let's see what that looks. Let's hit the play button, and it just moves the object by 10 millimeters, and it stops there. And we can hit reverse, and it moves 10 millimeters backwards. And we can change the end distance. Let's change it to 200 millimeters, and let's move it by 200 millimeters and it stops, and hit reverse and it comes back. So the length of the rail was 500 millimeters. If I enter 500 millimeters and hit move, it's going to go and end at the end of the rail. No, it will go beyond the rail because the drive constraint is driven by the flush constraint, where the flush constraint is done. It was between the surface of the box and this surface of the rail. That's why it moved a little bit extra, which is going to be the width of the box, which was 99 millimeters, right? So 500 minus 99, don't try to do math, just use these equations and hit OK. So let's go back. Let's go back to the beginning and hit play again. Let's see where it stops this time. It goes back to the end and it should stop flush with the end of the rail. Yes, it did. So let's go change this to, again, maybe 400 millimeters. So that's 500 minus 99 is 401. So let's change it to 401. And let's hit this double arrow button on the bottom right of the drive menu. And you will see a bunch of other options here. The first option is drive adaptability. We will have some sub-assemblies in the future, which can have components that will move within the sub-assembly. We will talk about that in the future videos with more complex assemblies. Collision detection, we can technically create an obstacle on this path, and we can basically do a bunch of other things that we can simulate the collision as well. We will talk about that in the future videos as well. But in this video, what I want to talk about is the increment and repetitions. Increment right now is set to 1 millimeter. So that means that it is moving the object with 1 millimeter increments. It is moving 1 millimeter at a time. So you can see this in the position on the top of the menu. So you can see that it is moving 1 millimeter at a time. Let's go back to the beginning again. And you can change that to total number of steps. So right now it is set to 401. This UL stands for unitless, meaning that it's just a quantity of the steps. It doesn't have a unit. So let's just hit play, and it is moving based on the total number of steps that you assign. It automatically converted 1 millimeter increment to 401 unitless entry. So you can just change these values and basically move the object based on the step count. Let's go back to amount of value and leave it at 1 millimeter and change that to 10 millimeter this time. And let's move it backwards. Notice that it moved a lot faster. You can change it to 50 millimeter at a time. It will move a lot more faster. So let's go back and let's talk about repetitions this time. So with repetitions, let's change this back to maybe 10 millimeter. Let's see if it moves fast enough. Yes, it does. So let's go back to repetitions here and change repetitions to start and start. And let's just hit play. It moved and it just basically did the same thing because the repetition number is 1. Let's change that to 10 and hit play again. Notice that it moves front and back 10 times. We are simulating the repetition, but we are also telling Autodesk Inventor how many times it needs to go from start point to the end point, from end point to start point. And again, that's a unitless number. So this is the drive constraint. And another detail with the drive constraint is you can always record this motion. And if you want to add that to a presentation maybe, or if you want to share it with a colleague and you want to simulate this motion. And don't confuse this with the IPN, a presentation mode of Autodesk Inventor. After the essentials section of the tutorial, we will talk about the presentation mode as well. But this is just a drive constraint that helps us simulate the motion, and we can always record it. So go ahead and try to create assemblies on your own and create objects and try to move those objects on the other objects using drive constraint. And we're going to talk about it more in the future. But for now, this I believe is a good example. I've seen so many different versions of this in the industry. For example, like conveyor belts, you can design a conveyor belt and simulate how the objects on the conveyor boxes, for example, on the conveyor belt would move. I used it for some automation, equipment, like you would have servos and cylinders, and you would simulate how the objects would move with those servo motors and the cylinders. So there are so many different applications of this, and in the future, as we do more exercises, you will see that it is very helpful and it's really fun to work with. But until then, This is the end of the video. Please don't forget to like and subscribe. See you in the next one. Thank you.